control, the contact control, then we really care about the deep switch. Otherwise, it's not working. You already experienced, right? And so for the AHU controller and also DDC mode bus, this communication type. The deep switch should be on. So when you did the first case, some team had experienced the product is turn off again and again, right? Have you seen that status? See, because if we are not turned on, and we just keep the turn off, which is the contact signal control. Contact. Signal like this. Then see if you make the LG control, but you set the contact signal, but actually in the Comm.kit there is no contact. No contact means operation off. That's why when you try to do edge control, but when you turn on and you turn off, because the deep switch was set by the contact control. So I think this is one of the important things to do, check on the field, right? And also we found that the communication speed of this product is 996, 100 bps post generation. Also it took about 8 or 10 minutes to auto addressing, right? So also somehow one or two teams has failed to auto addressing, but after resetting, then finally found the address by the second time. So it took like 20 minutes, right, to get to find the addressing. So and also some team had experienced that when the deep switch changes and then did not reset, or the wire change did not reset, somehow the CH05 it happened, right? So by reset, it almost issue is removed, but partly I think the channel 5 error is related communication, but also if we connect, so many teams make the connection in CH01, which is the Modbus communication, but many teams make mistake and put the CH01 to wires, and then I think that make the CH05 for the communication error. And so after we made two cases, case 1, case 2, and some team tried to make the edge central controller with the internal controller, and it works, right? Yes. So it works with the central controller, and also some team made the 2DS call scenario, so which is communication kit into communication kit. So one audio, we made the jump for the multiple IDU, right? And we have this simulator, and it gives the signal to the Comm.kit, and also you set the master and slave, and the temperature sensors, one remote controller, and jumping, and that was working. So it means you can make the multiple coils for the large capacity by make the looping jump. So okay, what else? So this is the summary of the last days. So, okay, and so before start to supply air, I just share the information about the most cost regarding return air. In the PDB, there is a first point in the end of the PDB data group. Also, you already saw the backnet gate point in the installation manual of HBacknet. Same as the backnet, this kind of the list shows which function is possible and which function is not possible. Because we have to deliver our product information to the BMS engineer to let them understand which function is possible and which is not. So this is a little bit different from the backnet, and I just briefly introduced about how to see this one. So there is number 6, 1, 2, 3, 4, 5, 6. Number 1 and 4 is lead information. So number 1, 2, 3, 4 is the status, like the on-off status, mode status, temperature status, error status, right? So it means if there is the comp status written here, it means the BMS engineer can see the comp status. So if the BMS engineer asks, do you have this function? Then you can see the list, yeah, we have this function, and then you can deliver this information. So this is like the agreed the protocol. So Modbus engineer, BMS engineer easily know if we deliver this information. They can find out which function is possible and which is not possible. So 1 to 4 is the status. It means we can see the BMS engineer can see the status of our product. And 5 or 6 is control. It means the BMS engineer can control operation on off, mode lock, fan speed lock, target temperature and operation mode, fan speed, target temperature, etc. So if we deliver that information, the BMS engineer can make their project according to this table. So when you have the meeting with the BMS guy, if they ask you about Modbus, you can deliver this page written in the PDB. Okay. One more thing. One more thing. So yesterday we made the configuration like audio and Comm.kit and remote controller and some DDC signal and sensors. We made sensors. Power. So what if the spec engineer may have ordered the I/O module for zero temperature control? So previous model PRCK1 sometimes this one is delivered with the I/O module multiple, right? You know about this? Huh?
We did not experience this case. We used to
Ah.
have only the
Okay.
communication.
Okay. Okay. Then, so you are not commonly use I/O module.
No, rarely.
Rarely. Okay. Okay. So. Okay, let's see the supplier kit. 네. 이건 좀 앞쪽에다 치면 페이지 앞쪽에 있습니다. 페이지 yeah 23. Okay. Okay, let's see briefly the supplier kit and then go deep and deeper. Okay, like yesterday. So I will do 2 and 3 hours theoretical part, and then we go downstairs, and then we will do wires like yesterday. Okay. So this is the supplier kit, a bit wider, and also it is same specification of the sensor, like in and out, and the air thermistor, and the key, and the big one, the main module.
Main board is
Sorry, I'm looking for the
Separated one.
separated one. So this is the main module with the element help to
you want like this one.
yeah, to let them see.
One? How many one?
Also,
Table one.
one table and each
One table.
Yeah. So this one is the main module. This is the we call communication module, which is just the same in the return air, right? So this guy control the GX coil, then this guy control the audio capacity. Okay. I have also question about the controller installation for the local supplier or third party DDC. Because we yesterday we discussed about the risk of the increasing the temperature inside, and so when you have the project for the AHU which is for the outside, so probably there is some controllers will be installed outside together, electric part or some control part. So are they installed in the metal or plastic? I just want metal with the but it's exposed to the sun.
They are installing not only the control panel, they are installing a full panel which has a starter panel and the control panel. So all the MCCBs, ELCBs are there in the panel, and on one side there is the GDC panel.
Oh, it's outside.
Outside in the exposed area, in that case they have the fans.
Inside.
No,
Inside the airflow.
Yes, airflow for the fan, this enclosure.
Enclosure.
So one side a small filter will be there. From there the air can be sucked, and on the side it will show outside.
So they make the same temperature
Outside.
outside. And plastic enclosure sometimes, no?
Huh?
I found the enclosures information from the manufacturer, like Schneider.
No, I haven't seen it.
The metal with the fan. Okay. Okay, thank you. And and the size is 380 millimeters and IP66 grade. Okay. Okay. Wide one is main controller, control the audio capacity, and has some UI and DO function. Okay. So first of all, coil capacity is set by the deep switch, just same as written. And the previous one is not available to install the central controller. Now it's available. Okay, we'll see. And what the protocol is embedded, just the same as the written. Okay, let's go more deeper. So we will like yesterday, we will discuss about the supply product.
How to set capacity?
So the capacity is just the same as the by communication key. So deep switch number 4, SW4, you can set the capacity.
SW4.
Yeah. The capacity is set by this line. This line is the deep switch coil control. Controlling this coil. Okay. So like yesterday, I explained the 3 control method and how it operates, right? So we have the LG control and contact by DDC and Modbus control by DDC, right?
Second.
Okay, so we have LG control, and contact, DDC contact. So before discuss about the detail, so I want to discuss why supply air. So why supply air matter? So to anybody who share your experience or knowledge about the supply air.
Actually, it's important in the fully fresh air 100 units, especially in operation rooms and medical applications. So, because all there will be no ATM, so we take must take importance of fresh air supply.
So because of the hospital, the surgery room, special room, so the HV engineer there is some specification with supply air. I think to avoid the infection, so the temperature should be like 12 degree, and the relative humidity is like 20 to 30 or 40. So it have to be lower to avoid the infection. So this kind of information is written from AHU or the book AHU guide and local regulation to make this kind of the air quality. So to do that, to supply air conditioning is one of the options, right? Dehumidicate the water and make the lower temperature is one of the application. And what else? So also UAE used Dubai used the fresh air for common area. Yeah. Also, do you have
Have
any?
you used FHUs for kitchen purpose?
Kitchen?
The restaurant kitchen?
Yeah. Because in case of the kitchen area, so there's a lot of heat load, but we don't need to cool whole area. We just locally provide the cold air, right? Like directly ducted located to the kitchen and supply to the I guess to the person who are doing some cooking. So also.
But do you recommend to have such like that?
Yeah, so in case of the large space, so when we have the large space of large heat load, sometimes providing the okay, I explain so if heat load is like this, always the machines providing capacity is always way higher than what is required to avoid the cooling issues. But if there is so large space, if we fill all this area, the height is very high, the capacity should be very huge. But in case of this kind of the large building, so the people are just standing below the floor level. No need to heat up the whole room. So in case one of the also you can make the return air control, but also you can just flow the cool air to make just this area cool by the diffuser, with the fan, and the fan flow the airflow to the room one way, or the flow cooling. Some architecture makes the flow cooling. With flow cooling, in case of flow cooling, they request to us to supply air to make the zone comfort. So also there is another issue that so if this is the space, so if we provide energy with the return air, what will happen? So like she's mentioned that so compressor is not exactly modulate according to the heat load. Then so in the summertime the product itself is designed for the meet the maximum heat load. But sometimes it's okay. But like the autumn or here the early summer. So when like this kind of the not hot period or the winter period, and then heat load goes down, but still we are providing big capacity. Then we will get overcooling and So it's first it's not comfort, because in terms of the comfort it's way over. Also it's wasting of the energy. So if we make the constant temperature, provide constant temperature to the room, and then there would be make the more comfort zone or save energy. I think this is the reason for the using the supply air. And then I found the supply air AHU is very increasing over the world. So I was supporting European country, and then I found the sales amount. And then 3 years ago, the quantity was small, and it's getting increasing for the supply air. So probably you will have the project for the supply air. Okay. So I found here most space is overcooling because it's summertime is like 40 something, 42, 44. So the HVAC device is designed for the high maximum, almost maximum ambient. So yeah.
Especially in the malls. I get sick every time I get food. It's from outside. Very cool.
But still here, the energy, the regulation is not that strict and not tough. We are here building is consumes a lot of energy, but in the nearest future, they will the government will push the each company to reduce the energy. I'm not sure, but normally Middle Asia electric price or the oil price is cheaper, right? It seems like. So it's most of building is like overcooled. Yeah. So if you're a sales engineer, you can discuss with the building architect, building designer, and then make more comfort building using the supplier. Let's see. So previous model is like PR DCA0, right? This is the previous one of the AHU supply air. Here this is so have you any the experience about the product? No experience? Do you have experience about this guy? No? No. Only return. Because return is simple, easy. Okay. So I will first explain about the previous concept, which is also possible for this model, and then explain the energy control. Right? So there is AHU, GX coil, expansion valve, AHU, and Comm.kit fly. And so for the DDC control, DDC should sensing the supply air. So and then it feedback to the Comm.kit to 0 to 10 voltage, right? Then so for example, so desired temperature T equal 22 Celsius, and then DDC sensing, and then the current temperature is like the 25 something. Then DDC will compare to the current previous, and then okay, and then to give the 0 to 10 voltage signal like low voltage. Okay, audio should operate with around 90% capacity. Then okay, after couple of minutes later, so or they did check for TC. Okay, oh, TC is like 24. Okay, then they will keep 90%, and somehow TC is like current temperature is like the 19. Then DDC found, oh, it's way more, it's too low, and then they decrease the voltage like 8 volt. Okay, like so DDC check the current temperature and desired temperature, and then change the level of the audio capacity. So if they change the audio capacity, it means the T evaporator. The evaporator of the DX coil temperature changes. If our machine works 100%, more lower the TE. Okay. So okay. So this is the previous model. Also, this function is possible for the current supply controller, right? Any question? Huh? It's okay? Yeah. And now I'm going to explain about the edge control. Please. So, in case of the edge control, so high temperature can be set in the remote controller, right? So in the remote controller, you can set temperature and 20 Celsius, for example. Okay. Then the Comm.kit supply here has the air sensor, which locates the discharge part, and then this is the okay, it's confusing. Desired temperature is 20 Celsius. So every 2 minutes, so our Comm.kit compared to TD and TC. Okay. System not 20 degrees. But current temperature is if more higher than like 25. Then our Comm.kit increase the capacity of the compressor internally without making the 0 to 10 voltage. So and then okay, increase capacity make lower the evaporation temperature. And then if the evaporation temperature is lower, then somehow this current temperature will reach 20, right? And then it can go up and go down, we don't know, but if 20 Celsius goes down, like 19 or 18, then our product decrease capacity. And then if you see the cycle, you can find the target lower pressure is going up and down. So it will get more higher evaporation temperature. Okay. So by changing the compressor capacity, the evaporation temperature is increasing and decreasing, and then our products try to meet the desired supply temperature by modulating the module capacity. So this logic is embedded here, and without the commanding the zero to 10 voltage, and then it controls the capacity, the discharge temperature. Okay. So also this controller has some features. So in this product, yesterday we talked about return air. Return air has hysteresis, like if we set 20 Celsius, we have hysteresis for the plus 0.5 and minus 0.5. If the current temperature is over the range, the product will sum off, right? So on and off style return air, like the air conditioner. But this system supply air is always trying to keeping cycle on, always keeping cycle on, and modulates the temperature up and down.
It's more smooth.
Yeah.
It's like multi-beam inverters.
Yeah.
In case of VDC, now we are sensing the discharge temperature directly to the VDC or to the communication system.
This one?
Yeah, it's connected to VDC, the temperature, discharge temperature sensor.
So this one should supply, it will supply
For age.
supply for contact
For
control.
age.
So it's sensed by the VDC, not the communication device.
No, in case of this scenario. And this scenario sensed from outside. And if you have multiple control, you have more freedom.
Just, sorry, another question. Salam. He says when we have humidity, more humidity, let's say we have to increase the humidity inside. Also, it's sensed by, we can add another sensor.
No.
It's AHU. So the room, if it is a kitchen or something else, you'll have the humidification. And if it's like FAHU, then we have indicating. Yeah, because I think here in the first section, he told about the coil, he did not tell about any heat pipe or anything.
Simple.
Simple one.
Simple one. You can add dehumidifier.
Yeah, dehumidifier also. When we have totally fresh air, about heat pipes or heat wheel can be built in that and get it.
You mean more control humidity? Yeah, let's say I have increased some humidity inside. Like I have humidity. Maybe I have to add some dehumidifier inside the coil. In the sections.
You mean you want to install humidifier?
Yes.
inside the group.
Humidifier?
So we have in Dubai we have such problems. Mostly cigar bars, shisha areas. I have done some works in shisha areas, cigar bars. People smoke, and all the smoke will be coming towards the AHU and FAHU. Same smell circulates. They are using in this way also. So in these cases, we have any option to remove the steam purification or autumn smell from the return air and use the fresh air again. We have these options.
Actually, for such cases,
The people
the same air should not be recirculated.
Whatever they cannot refresh it.
Huh?
People they are using in such way, using AHU. It's like in the design of the building, they don't say that it's only AHU. The moment they come, they use a cigar bar. The moment after 1-2 years, they call us again. We want the design to be changed. I face this issues. That's why.
So in such cases, always put some fresh air
Yeah.
into the area and
The cooling is affected. Always they wanted 19-20 degrees. People smoke and even they want the cooling.
Add additional units somehow.
It doesn't succeed. It doesn't work out.
So, hydration issue, supply always supply, internal always go out.
Yeah.
Maybe it is changing. Okay.
if we decrease the capacity of a compressor, then what will be the impact on delta T?
Oh, this is a difficult question.
Across the coil, on coil and off coil. If we increase or decrease the, see now normally we get 5 degrees delta T across the coil. So if we increase or decrease the capacity, do we get any change in this delta T? Or it will be always same? Of course, content of heat will be reduced, but the temperature will be same.
Change some body logic. I don't know.
So probably.
But it's not important. If you not achieve the target supply, it's increase.
Yeah.
And if target achieve this one, decrease. This concept. It's not important to coil temperature and supply
No,
temperature.
what happens? See, for example, now compressor is running at 50% capacity, and the inside load increases. So you will not be achieving the supply air temperature because
Yeah.
coming air temperature is hot,
Yeah.
and your delta T is fixed,
Yeah.
5 degree. Then you increase the capacity of the
right,
compressor
right.
from 50% to 60%.
Right.
So when you increase the capacity, you are actually increasing the liquid coming inside the
Right.
coil.
Right.
So in that case, you are increasing the latent heat and specific heat removal.
Yes.
But you are not changing the delta T. Delta T remains same.
I mean, even if it's the same, it's not important. Just we are achieve supply of temperature. You mean some fluctuation because of fluctuation?
See why I am asking this, because I wanted to know the scenario when the load is very less on the system and it is running at minimal capacity.
Yeah.
Around 15%, 20%. What is the minimum? Top minimum?
40%. 40%.
40%.
If you have two systems,
Yeah,
240 is 20.
20%.
If you have two systems.
Okay. So it is running at 20% capacity and still the load is just matching over there. So, but our delta T is fixed. So if as we are maintaining the supply air temperature, and suppose supply air temperature we fix it at 16 degrees Celsius. When the load is constant, when the compressor is running, because of 20, supply air temperature is achieved. You cannot go less than 20%. So you will switch off the compressor in that case. Once you switch off the compressor, the supply air temperature will start increasing. So it will increase. Once the supply air temperature increases, you cannot increase the capacity because compressor is stopped. So you have to switch it on. So when the minimal capacity is there, the compressor hunting will happen. On. So is it advisable, or what will be the solution for that? Or is it again that time also it is taking 3 minutes gap?
이게 다르지 않나?
If it is taking 3 minutes gap, then within that 3 minutes supply temperature will shoot up. Because compressor has
my
taken 3
opinion
minutes
on
gap.
that gain value regarding the delta T, it should be different gain value. I mean, 20 degree pipe temperature, in that case, I mean, less load, delta T should be less.
That's what I asked it first. My
Yeah.
first question was that.
They apply some gain value for that.
My first question was that only for
So,
that.
so
If you are reducing the delta T, then this problem may not come.
Your solution will be solved when it is PXV.
yeah.
That is PXV will be
Yes.
solved. When you have EEV, it will not solve because hunting will happen. EEV is a bubble type, so it doesn't control the expansion properly. So hunting will be happens and the pressure will be there. So temperature will be going, coming within 5 minutes, start up, down, start down, start down.
Yeah. The problem is that as you mentioned, also I received the same test. If the current heat load is the okay, so means lowest capacity is 40%, then heat load of the building is like 20%. It's low. And minimum. In DDCY,